Hello friend, last lecture we have seen the numerical on slope and deflection, as well as we have seen the Macaulay method. Okay, today we will see the numerical on the slope and deflection. Okay, let's see what is the given in this numerical. You have given which type of the beam. Here it is support and this beam is extended behind the support. Okay, we have seen in the unit number 2, right? This type of beam is called as a overhang beam. Okay, here is a D to E portion. There is a UDL is at the value is 10 kilonewton per meter. Here is a couple is at the 3.25 kilonewton meter. Okay, one support is given at A point and another support is given B point. Then we want to find out the value of theta A and theta B. Okay, both value of we can say the dy by dx at A point, dy by dx at B point. Means we want to find out the slope in the form of EI. Then how to calculate the slope? We have seen the Macaulay method. Okay, with the help of that Macaulay method, you can find out the value of slope as well as deflection. But here we want to calculate only the slope. Before going on this, you know the value of support R1 and R2. Okay, we will find the first step is a. You know what is the first step in the Macaulay method? First step is a determine the support reaction. Determine support reaction. I will find out that support reaction R1 and R. You know that vertical iron X positive summation of Fy is equal to 0. Okay, here is a one A point Ra plus. We will write Rb. Okay, R2 you can write. Okay, then there is only one force is at UDL 10 into 3. Here it is minus 30. 10 into this 3 plus 2, 5. Means 50 is there, is equal to 0. This is the equation 1. And second, I will take the summation of MA is equal to 0. Okay, I will consider clockwise positive. Clockwise positive, summation of MA is equal to 0. Okay, here MA is equal to 0. Then check that here is a anti-clockwise movement is at as per minus 25, and UDL is at there is a UDL again. This is going clockwise direction. UDL. This UDL is a plus 10 into 3. 5 is there. 10 into 5 into where is that? Where is that? 5 by 2. Okay, this act at the center here. Then 5 by 2 and this 2 meter distance up to the A. Up to the A means plus 2 is there. And one more force is at this is going anti-clockwise direction. That's why RB minus RB into up to the distance A. 3 plus 2 5 minus RB into 5 is equal to 0. If you have find out the RB, then you will get the RB is equal to 40 is there. If you have put this value in that equation, then you will get the RA is equal to what? 10 is there. Okay, take that. This is in kilonewton. You will get this value in kilonewton. Once you have calculated this RB or R1 is 10 and RB is 40 is there. Then what is the second step? You have to consider the section XX at a distance x from the left end. See guys, Macaulay method having some limitations. You have to check where is the UDL is at up to the last. If this UDL is at here up to the last, then you have to consider the section this side. Okay, but up to the end, here is a UDL is at. That's why we want to consider the section XX. Okay, the last portion of the given beam from the left hand at a distance x. I will consider. This is the second step. You have to consider the section xx in the last term of the beam up to the distance x from the left hand. From the left hand, I have considered here section xx from the left hand at a distance cx. Then next step is you have to take the moment about that section xx. You know the mxx is equal to, you know that mxx is equal to d square, sorry, ei into d square y by dx square. We know this equation. Okay. With the help of that, take the section xx about the take the moment about the section xx. Then check that this Ra or R1 is going clockwise direction. That's why 10 into x, 10 into x. This is the first compartment. Make the compartment. Then if the moment is at, then you have to write there. Find out this remaining distance up to the section xx, x minus 1. If you have minus x minus 1, then you will get the remaining distance x minus 1. This is the 25. Okay, this is anti-clockwise direction. Minus 25 into, you have to multiply by the distance. Here Maxwell's method having some limitation, and if you have given the couple, then make the rest to 0. Mark the rest to 0. Remember that. This is very important. Okay. If the couple is at, there is a rule in Maxwell's method or assumption. If the couple is at, then you have to mark the distance rest to 0. Distance rest to 0. Then next one here is the UDL is at. See, this UDL is going again anti-clockwise direction. That's why minus. What is the UDL value? 10 into 5 is there. 50 is there. 10 into 5 is there. Check that. Minus or no. We are considered up to the x. Right? X. We don't know this distance. This distance is x minus 2 is there. Means minus 10 into x minus 2. X minus 2 into x minus 2 divided by 2 is there. 2 is there. And last section is a plus. This is going clockwise direction, plus this side. This R2 is equal to 40 or RB is equal to 40. And what is this distance? Remaining distance from B to this section xx. This x minus 5 is there. X minus 5 is there. This is the equation number 1. Okay. This is very important equation. Guys, check once again this equation. Okay, if you written wrong this equation, then you will get the wrong answer. That's why be careful when you find out the equation number 1. Okay, once you got the equation number 1, then next step, integrating equation number 1. Okay, with respect to x, integrating equation 1 with respect to x, then we get, what we will get? I will check that ei into dy by dx is equal to, then this 10x, 10 into x, integration, what is the x integration? X square by 2 is there, and you have to write the constant plus c1. Then second one minus 25, x minus 1, rest 1 divided by 1 is there. Okay, then next minus 10 into x minus 2 into x minus 2 means x minus 2 bracket square. If you have taken the integration, x minus 2 cube divided by 6, 2 into 3, 6 is there. Then again plus 40 into what? X minus 5 plus 2 divided by 2. This is the equation number 2 is there. Then check that next step, again integrating the equation number 2. Integrating equation number 2, we get, what we get? Yes, anybody? If you have taken the integration of that, ei into y is there, ei into y is there, then check that 10x cube is there, x square the integration, x cube divided by 3 into 2, 6 is there, plus c1 into x plus second integration constant c2. The next one minus 25 into x minus 1 bracket square divided by 2 is there. The next minus 10 into x minus 2 bracket raised to 4 divided by 24, 6 into 4. And last section 42 x minus 5 cube divided by 6 is there. This is the equation number 3. Once you have got these 3 equations, then easily you can find out the slope value. Once you have calculated that 3 equations, then use the boundary condition and find out the constant value. Okay, how to find out the constant value? Step number 5, using boundary conditions. Using boundary conditions. How to use? We have seen the boundary conditions, right? In the first lecture. Check that x is equal to 0, then y is equal to 0. Check that here. If you have taken the x is equal to 0, then what is the deflection at the end of the beam? We will get also 0 at the support. Then, if you are putting this value in that equation up to the first compartment, check that up to the first compartment from equation number 2. If you are putting, check that y is equal to 0, this statement will be 0, this x is equal to 0, c2 is equal to 0. You will give c2 is equal to 0 from equation 2. And second boundary condition, what is the second boundary condition? X is equal to 5, y is equal to 0. Another support, where is the another support here? What is the distance from the A point? 2 meter plus 3 meter, 5 meter. X is equal to 5 meter. Y is equal to 0. We have seen in the simply supported beam. Then we can write the y is equal to 0. Y is equal to 0. Okay. Then put this value in that equation. Equation number 3. From equation 3. On equation 3, we will give the value y is equal to 0. 0 is equal to, check that, 10 into 5 cube divided by 6 plus c1, we don't know the c1, we want to calculate 5 c1 is there, plus c2 is 0, minus 25 into x, 5 minus 1 bracket square divided by 2, then again minus 10, 5 minus 2 bracket raised to 4 divided by 24. Okay, take up to this compartment. Don't consider that we can last compartment 40. Okay, up to the this. That's why we are doing the compartment. Don't consider this part. Only consider up to this B part, left side part. Okay. If you are solving this, then you will get C1 is equal to, check that, 5.0834. And this is the constant value. You will get C1 is equal to 5.0834. If you are putting this value in that equation, equation number 3 and equation, which equation? Equation number 2. This equation you will give the dy by dx at A point, dy by dx at B point. We will check that. Okay. We will keep as it is that equation number 2. You have to check that. What we want to find out? We want to find out which value? Dy by dx at A point. What is the value of dx at left hand? X is equal to, we want to put 0. Okay, here x is equal to 0. Put in equation 2. Okay, and you have to consider the one only one compartment. You have to consider the only one compartment up to this part, left side part. Okay. Then what is the value of that in the form of EI? I will write directly dy by dx at A is equal to, check that, 10 into x square divided by 2 means what? X value is 0. You will get the 0 plus C1. What is the value of C1? 5.3, sorry, 0834, and I will shift this EI is there, na? EI into dy by dx. I will shift that side, then divided by EI. This value we will get in the radian. We don't know the value of EI. That's why we want to find out in the form of EI. Okay. Once you have got this value, then another equation we want to find out the dy by dx at the B point. Okay. Then how much value we want to put? X is equal to, take that distance, 2 plus 3 is equal to 5. Then you have to put the x is equal to 5 in that equation. Then I will take that dy by dx d at point B. I will shift that EI this side. Okay, 1 by EI I will write here. Okay, then check that the remaining value x is equal to 10 up to the third compartment. 10 into 5 square divided by 2 plus 5.0834. Okay, what is the value of C1? I have put minus 25 into x minus 1, 5 minus 1. Then again minus this value, 10 into 5 minus 2 bracket cube divided by 6 is there. Okay, I have put this all the value in the equation number 2. Then you will get the equation number 2 will give the which value? Equation number 2 you will give the dy by dx at B in the form of 1 by EI. This value you will get minus 14.916 divided by EI. If you calculate this value, then you will get the minus 14.916 divided by EI. In this way you have to solve the numerical. Guys, remember that one thing. I will give the example. Suppose there is a simply supported beam is given, and you have given this UDL in left side. Then you have to consider the section in left side. Okay, and you have to consider the distance x from the right end. Remember that condition. Again, one more condition. Suppose in this any beam you have given UDL at the middle or any place. Okay, they are not touched to the end. Then you have to extend this UDL. You have to extend this UDL up to the last at any one end, and same UDL is at in upward direction. This is the limitation of the McCree's method. Okay, this is very important. If you have given the UDL this side up to the end, then you have to consider the section XX in the left end. And if you have given the UDL at the center or any position, they are not touched to the end, then you have to extend up to the end, and same UDL is at in the upward direction. Okay, today we will stop here. Next lecture we will see the next numerical.